Hello. I'm doing this problem because most of the students had difficulty in this. And so l- this is a table given, and it's like in relation with grams. Like in 1 kilogram, there are 10 raised to power 3 grams. In 1 hectogram, there is 10 raised to power 2 grams. So this are in relation to the grams each. Like in 1 nanogram, there are 10 raised to power minus 9 grams. Okay. So let's do A. So it says how many times larger is a kilogram than a nanogram. So basically, we want a ratio of kilogram over nanogram. Okay. So as we see, in 1 kilogram, there is 10 raised to power 3 grams. Okay. So, and in 1 nanogram, there is 10 raised to power 9, negative 9 grams. Okay. So we can put 1 kilogram is equal to 10 raised to power 3 grams. Okay. And 1 nanogram is equal to 10 raised to power minus 9 grams. Both are in grams, so we can find the ratio. Okay. Which will give us how many times kilogram is larger than the nanogram. So this is 10 raised to power 3 over 10 raised to power negative 9. We know this formula of exponents. AM is over AM is equal to AM minus N. Okay, so we'll apply that. So this will be 10 raised to power 3 negative 9. Okay, because it comes up, so it becomes, so it will be 10. So negative times negative is positive. So 3 plus 9, so 10 raised to power 12. Okay, so a kilogram is 10 raised to power 12 times of nanogram, 1 nanogram, okay, or 10 raised to power 12 times of nanogram. It's heavier, 10 raised to power 12 times larger than a nanogram. Okay, 1 kilogram is 10 raised to power 12 times larger than a nanogram. Okay, and we have to leave the answer in positive exponents. So it is a positive exponent. Now let's do B part. Okay, so in B part, it will be, let's do in another page. Okay, so let's do B. How many times smaller is a milligram than a hectogram? So again, it is given in terms of grams. So first we'll put milligram. So we'll see that 1 milligram is equal to 10 raised to power minus 3 grams. Okay. And hectogram is 1 hectogram is 10 raised to power 2 grams. Okay. So, and both are in grams. So we can say that it's how many times a milligram is smaller. Okay. So we can say if we find the ratio of milligram over hectogram, so it's 10 raised to power negative 3 over 10 raised to power 2. And we have to write the answer using only positive exponents. So this will be 10 raised to power 5. It means a milligram is 10 raised to power 5 times smaller than the hectogram. Okay. So a milligram is 10 raised to power 5 times smaller than a milligram and then a hectogram. Okay. In 1 hectogram. Okay. So now the C part, which is greater, 10,000 milligram or 1,000 decigram. So uh, in 1 milligram, okay, there are 10 raised to power minus 3 grams. Okay. So in 10,000 milligrams, okay, how many grams will be there? So it will be this milligram and milligram cancels. So basically we put here in 1 milligram there are 10 raised to power minus 3 grams. So in 10,000 milligrams, now how many grams will be there? So as we see milligram cancels, so the answer would be in grams. So this is for 10 raised to power 4. Okay, and this is 10 raised to power minus 3 grams. So if we again use this formula, A is equal to M, A is equal to N, is equal to A is equal to M plus N. So this is 4 minus 1, 4 minus 3 is equal to 10. So there will be 10 grams. So this 10,000 milligram is equal to 10 grams. Okay. Now, again changing decigrams to grams. Okay. So it is 10,000, 1,000 decigrams. Okay. So in 1 decigrams, how many grams are there? 10 raised to power minus 1. So 10 raised to power minus 1 gram is equal to 1 decigram. So 1 decigram is equal to 10 raised to power minus 1 gram. So if we cancel here, decigram cancels. This is again 10 raised to power 3 times 10 raised to power minus 1. So this gives 10 raised to power 2, which gives 100 grams. Okay. So which one is bigger, 10 grams or 100 grams? So definitely 100 grams. It means 10,000 decigrams, sorry, 1,000 decigrams was larger than 10,000 milligrams. Okay, so let's do some more questions. But basically, in this, what we do is we find the factors and then we simplify here, okay, and apply the rules of exponents. Let's do question number 16 also. Yeah. So in these problems, we have to find whether there is a growth or decay. So one thing we have to remember, if there is any number like this is A, okay, raised to power t, t is the time. If this A is greater than 1, then definitely with time, this value will increase. Okay, it will be, the graph will be like this. Because A is greater than 1, so with, with every t increase, it's increasing. Okay, but if it is less than 1, suppose like it is half, and as the time increases, this becomes more lower and lower and it decreases. There is a decay. Okay. So I'll show you here. So this is like y is equal to 3, 1 plus 0.88. We'll write like this. Okay. Times t. Okay. So we see that it is increasing. It is greater than 1. Okay. The formula here, this is in the form of y is equal to a, where a is the principal, and 1 plus r t. Okay. R is the rate. Okay. Rate of change. So here the rate of change is 0.88. Okay, or we can say 1 plus r is equal to 1.88. So r is equal to 0.88. Okay, and the rate of growth or the percentage growth or rate of growth is 88%. Okay. So it's simple like that. Suppose this is 2, okay, and time is increasing. So what is 2 raised to power 1? 2. 2 raised to power 2? 4. So with every increase, this is increasing. So it is a exponential growth like this. Okay. But at the same time, if this is suppose half, okay, and this is t. So with every, what is half raised to power 1? It is half. What is half raised to power 2? It is 1/4. Okay. So it's So it is decreasing with every 1 raised to power, half raised to power 3, it will become 1 over 8. So it will decrease. So it will be exponential decay. Okay. So let's do the second one, which is 1 over 3. So the second, 15th one is y is equal to 1 over 3 and 1.26t. Okay, 1.26t. So again, comparing it with this, y is equal to a 1 plus r t. So this is uh, so 1 plus r is equal to 1 plus 0.26. So r is equal to 0.26. Okay. So rate of growth is, so definitely this is more than 1. So 0.26 is the rate of growth. Okay. And percentage wise, if we see, it is 26%. So rate of growth is 26%. So in this case, we see that this is less than 1. 3 by 5th is less than 1. So with as the t increases, this ratio, because the denominator increases, this ratio will decrease. So we can put like y is equal to a 1 minus r t. Okay. And 1 minus r is less than 1. So this is a decay. Okay. And decay factor is 1 minus r. Okay. So 1 minus r is 3/5. Okay. So it's minus r is 3 by 5th minus 1. So r is 1 minus 3 by 5 is 2 by 5 or zero point 0.4. Okay. So rate of decay is 40%. Okay. So when this 1 plus r is less than 1, when this portion is less than 1, this is a, and suppose this is kt. So if this function is less than 1, then it is decay. And when it is greater than 1, then it is growth. Okay. So if you have any doubt, please get back to me. Thank you.